In the realm of machine learning, configuring compute resources for a job run is a critical step. This process involves selecting the appropriate computational resources to ensure that your model training and deployment are efficient and effective. The right configuration can significantly impact the performance, cost, and scalability of your machine learning projects. This presentation will delve into the various aspects of configuring compute for a job run, providing a comprehensive guide to help you make informed decisions. Compute resources refer to the hardware and software infrastructure required to run machine learning jobs. These resources include CPUs, GPUs, memory, storage, and networking capabilities. The choice of compute resources depends on the complexity of the model, the size of the dataset, and the specific requirements of the job. Understanding the different types of compute resources and their capabilities is essential for optimizing performance and cost. There are several types of compute resources available for machine learning jobs. CPUs, central processing units, are general-purpose processors suitable for a wide range of tasks. GPUs, graphics processing units, are specialized processors designed for parallel processing, making them ideal for deep learning tasks. TPUs, tensor processing units, are custom accelerators developed by Google for neural network computations. Each type of compute resource has its strengths and weaknesses, and the choice depends on the specific needs of your job. Choosing the right compute resource involves evaluating the requirements of your machine learning job. For instance, if your job involves training a deep learning model with a large dataset, a GPU or TPU might be more suitable due to their parallel processing capabilities. On the other hand, if your job involves running multiple smaller tasks, a CPU might be more cost-effective. It's important to balance performance, cost, and scalability when selecting compute resources. Azure Machine Learning provides a range of compute options to support various machine learning workloads. These include Azure Machine Learning Compute, Azure Kubernetes Service, AKS, and Azure Databricks. Azure Machine Learning Compute is a managed service that allows you to create and manage clusters of virtual machines. AKS provides a scalable and flexible environment for deploying containerized applications. Azure Databricks is an analytics platform optimized for big data and machine learning workloads. In Azure Machine Learning, you can create and manage compute clusters to run your machine learning jobs. A compute cluster is a group of virtual machines that work together to perform parallel processing. You can specify the size and type of virtual machines, as well as the number of nodes in the cluster. Azure Machine Learning automatically scales the cluster based on the workload, ensuring that you have the right amount of compute resources at all times. A compute target is a cloud-based or on-premises resource where you run your machine learning jobs. In Azure Machine Learning, you can configure different types of compute targets, such as local compute, remote virtual machines, and cloud-based clusters. Each compute target has its own configuration settings, including the type of virtual machines, the number of nodes, and the scaling options. Configuring compute targets allows you to optimize the performance and cost of your machine learning jobs. Optimizing compute performance involves fine-tuning the configuration of your compute resources to achieve the best possible performance for your machine learning jobs. This includes selecting the right type and size of virtual machines, configuring the number of nodes in a cluster, and setting up auto-scaling policies. Additionally, you can optimize performance by using techniques such as data parallelism, model parallelism, and distributed training. These techniques help to distribute the workload across multiple compute resources, reducing the overall training time. Managing and optimizing the cost of compute resources is crucial for the success of your machine learning projects. Azure Machine Learning provides several tools and features to help you monitor and control costs. These include cost management dashboards, budget alerts, and cost optimization recommendations. By carefully selecting the right compute resources and configuring them appropriately, you can minimize costs while maximizing performance. Additionally, using spot instances and reserved instances can further reduce costs. Scaling compute resources involves adjusting the number and size of virtual machines in your compute cluster to match the workload. Azure Machine Learning supports both manual and automatic scaling. Manual scaling allows you to specify the number of nodes in the cluster, while automatic scaling adjusts the number of nodes based on the workload. Scaling helps to ensure that you have enough compute resources to handle peak workloads, while minimizing costs during periods of low activity. Monitoring and troubleshooting are essential aspects of managing compute resources for machine learning jobs. Azure Machine Learning provides several tools and features to help you monitor the performance and health of your compute resources. These include metrics dashboards, log analytics, and alerts. By monitoring your compute resources, you can identify and resolve issues quickly, ensuring that your machine learning jobs run smoothly. Additionally, troubleshooting tools help you diagnose and fix problems, improving the reliability and performance of your compute resources. To ensure optimal performance and cost efficiency, it's important to follow best practices for configuring compute resources. These include selecting the right type and size of virtual machines, configuring auto-scaling policies, monitoring performance and costs, and using cost optimization tools. Additionally, it's important to stay up to date with the latest advancements in compute technology and best practices. By following these guidelines, you can maximize the performance and cost efficiency of your machine learning jobs. Let's explore a case study of a successful compute configuration for a machine learning project. A company needed to train a deep learning model on a large data set. They chose to use Azure Machine Learning Compute with GPU-enabled virtual machines. By configuring auto-scaling policies, they ensured that the compute cluster scaled up during peak workloads and scaled down during periods of low activity. They also used cost management tools to monitor and control costs. As a result, they achieved significant performance improvements and cost savings. Configuring compute resources for a job run is a critical aspect of preparing a model for deployment. By understanding the different types of compute resources, selecting the right ones, and optimizing their configuration, you can ensure that your machine learning jobs run efficiently and cost-effectively. Azure Machine Learning provides a range of tools and features to help you manage and optimize compute resources. By following best practices and leveraging these tools, you can maximize the performance and cost efficiency of your machine learning projects.